All right, let's talk about something that's probably tucked away in your garage or basement, a metal box filled with a row of switches. These things are, and I mean this quite literally, the unseen guardians of your home. They are the first and last line of defense against an electrical disaster, and in this explainer we're going to pull back the curtain and see exactly how they work.
I mean, really think about it for a second. We use electricity all day, every day. We plug things in, we flip switches, but we almost never think about that invisible safety net that's there to stop a simple faulty appliance from turning into a life-threatening situation. So what is really happening inside that panel?
Okay, before we meet the heroes of our story, we first have to understand the villains. You see, electricity poses two very different but equally serious threats inside our homes. The first threat is just pure brute force. Think of the wires inside your walls like a pipe. They can only handle so much current flowing through them. If you try to push too much through, maybe by plugging in too many high-powered appliances at once, that wire gets hot, really hot enough to melt the plastic insulation right off, which can lead to sparks, arcing, and yeah, a very serious fire.
And then there's the second danger. This one's the silent one, the one most people never even consider. It's a tiny leak of electricity. An amount so small it would never start a fire. It wouldn't even make a wire feel warm. But if that tiny current decides to pass through your body, it is more than enough to be fatal. This is the silent killer our first line of defense is completely blind to.
So let's meet those first guards. These devices are all about stopping that first threat we talked about, fire. Their whole job is to protect your house and your equipment, but, and this is the key takeaway, they are not designed to protect you. For a long time, this job belonged to the humble fuse. The old-school porcelain ones were basically just a special piece of wire that was designed to melt and break the circuit. Simple, but kind of slow. The modern HRC fuse, though, is a massive upgrade. It's a sealed ceramic tube that's filled with quartz sand. When the fuse blows, the element inside vaporizes, and that sand instantly turns to glass, smothering the dangerous electrical arc in just milliseconds. Way faster and much safer.
But today, most of our homes use these, the Miniature Circuit Breaker, or MCB. Now, their biggest selling point is obvious, right? They're resettable. No more searching for a fuse in the dark with a flashlight. But the real magic is what's going on inside. They actually have a two-part brain for dealing with two different kinds of problems.
So the MCB is pretty clever. For those slow, gradual overloads, like having too many things running for too long, it has a bimetallic strip that slowly heats up, bends, and eventually, click, trips the switch. That's its thermal trip. But for a sudden, massive disaster like a short circuit, it uses an electromagnetic. This creates an instant, powerful magnetic force that just slams the switch open in a fraction of a second. That's the magnetic trip. Two different dangers, two purpose-built solutions.
So this is the really crucial thing to understand. An MCB will absolutely save your house from burning down. It's fantastic at what it does. But it has absolutely no idea if a tiny, fatal trickle of current is leaking through a faulty appliance and into you. For the MCB, that small leak might as well be invisible.
Now, to solve this very real life-or-death problem, we need a completely different kind of guardian, a specialist, a device that has one mission and one mission only, to save your life. Enter the RCCB.
30 milliamps. That's 30 thousandths of an amp. It is a ridiculously small amount of electricity. So small a normal breaker wouldn't even flinch. But it is the medically recognized amount of current that can send a human heart into what's called fibrillation, which is often fatal. This is the number that really matters.
An RCCB, which stands for Residual Current Circuit Breaker, just doesn't care about overloads or big short circuits. That's the MCB's problem. The RCCB is a detective. It's constantly on the lookout for a single, tiny clue, an imbalance in the current.
And the way it works is beautifully simple. A basic law of physics tells us that in any healthy electrical circuit, the amount of current going out on the live wire has to be exactly the same as the current coming back on the neutral wire. The RCCB uses a sensor that acts like a perfectly balanced scale, constantly weighing the two against each other.
But the moment you touch a faulty appliance, that deadly 30 milliamps of current takes a detour. It goes through your body and into the ground. It never makes it back on the neutral wire. And in that instant, the scale becomes unbalanced. The RCCB detects that tiny difference, that residual current, and it instantly cuts the power. We're talking in under 30 milliseconds. That's faster than you can blink, and it's fast enough to save your life.
And this staircase of safety really drives home why that 30 milliamp number is so critical. You can see there are other higher ratings, like 100 milliamps or even 300 milliamps. Those are used for other jobs, mostly for fire prevention in large industrial settings. But for protecting human life, especially in wet areas like your kitchen or bathroom, 30 milliamps is the one and only standard.
So we have the MCB watching out for our equipment, and we have the RCCB watching out for us. It kind of begs the question, right? What if you could just combine them into one ultimate guardian? Well, you can.
And this is it, the RCBO. The name says it all, a residual current breaker with overcurrent protection. As you can see here, it's literally an MCB and an RCCB built into a single compact body. It gives you fire protection and life protection, the whole shebang, all in one switch.
Now, the biggest practical benefit of this is something called fault localization. See, in an older setup, you might have one main RCCB protecting a bunch of different circuits. If your toaster has a fault, that one device trips and your whole kitchen goes dark. But with RCBOs on each circuit, only the faulty circuit trips. The toaster goes off, but your lights and your fridge, they all stay on. It's just so much more convenient.
Okay, so now that you know what all these different devices are and why they are so vital, let's get practical. Let's talk about what you can do right now to check on your own home safety.
And this is a really simple check you can do. First, go find your electrical panel. Take a look at the breakers. You're looking for any that are a little bit wider than the others and have a small test or T button on them. Those are almost always RCCBs or RCBOs. Now look closely at the label on the front. You're searching for its sensitivity rating. You want to see the number 30 milliamps, or sometimes it's written as 0.03A. This is absolutely crucial for any circuits that go to your kitchen, your bathrooms, or any outdoor sockets. If you don't see any, it's a really good idea to call a qualified electrician and have them take a look.
So let's just boil it all down one last time. Fuses and MCBs are there to protect your property from fire. RCCBs, and their all-in-one cousin, the RCBO, are there to protect people from a fatal electric shock. The magic number for life safety that you need to remember is 30 milliamps. And for the absolute best combination of safety and convenience, RCBOs are the modern gold standard. That electrical panel in your home isn't just a box of switches. It's the command center for your family's safety, and it's on duty 24/7. So after watching this, go take a look. Do you know what's standing between your family and an electrical accident?